For most people who are not familiar with how ships work, a ship leaving port might be comparable to a car leaving a parking lot. But of course, it's not as simple as turning the key to start the engine and then just driving off, especially for large ships. The whole process will require proper coordination and teamwork from the ship's crew. Berthing and unberthing of ships is a critical operation which involves the ship's deck and engine departments, with support coming from the dock workers, pilots, and tugboats as needed. For this episode, I'll be showing you how a ship leaves port, or basically what is known as departure procedures, which includes starting up the main engine and unmooring operations. A ship calls on ports to load or unload cargo, and ideally, as soon as the cargo operations are completed, the ship has to leave the port in order to start its voyage. Departure procedures start when the bridge gives the engine room a 1-hour notice. From there, the engineers will have to begin preparations in order to get the main engine ready to start. The first on the list would be to start an additional generator. This is in order to have more electrical power available for the additional machinery that will be needed during startup and maneuvering. For ships with diesel engine propulsion, typically the main engine has 4 ancillary systems: fuel, lubrication, cooling water, and starting air, all of which should be working within the required parameters in order for the engine to start. For this ship, however, our main engine is electronically operated, meaning it has no camshaft to drive the fuel injection and exhaust valve actuation. In place of the camshaft, it is designed with its own hydraulic system and electronically operated valves called FIVA, which stands for fuel injection and valve actuation. For the fuel system, the circulating pump is usually kept running, even when the engine is stopped. This is in order for the fuel to continuously circulate through the fuel lines. The same goes for the cooling water system. When the engine is stopped, the water is continuously circulated through the preheater and then to the cylinder jackets to maintain the ideal temperature of about 80 to 85 degrees Celsius. As for the lubrication system, the lube oil pump should be started at least 2 hours before operating the engine in order to ensure that lubricating oil is properly circulating through the system. If the ship will only stay in port for a short time, the lube oil pump is usually just kept running. The next step will be to turn the engine's flywheel using the turning gear. This is done to ensure proper lubrication of the cylinders, as well as the bearings and moving parts in the crankshaft. The turning gear is quite slow, so a few revolutions of the flywheel will take a few minutes. Before starting the turning gear, make sure that the indicator valves are open in order for the gases inside the cylinder to escape. While the engine is turning, the next step is to prepare the starting air system. The main engine is started by means of compressed air, so it's necessary to maintain the pressure in the air tanks. Typically, the maximum pressure these tanks can hold is up to 30 bar each, and they are automatically filled by the air compressor. During maneuvering, the main engine will be started and stopped as needed, so there will be increased demand for compressed air. An additional air compressor is put into service to make sure that the air pressure will recover quickly. After the engine has been turned for a few revolutions, it's time to stop and disengage the turning gear and prepare for engine trial. The engineers will inform the bridge that the engine is ready for trial. When the bridge confirms that everything is clear, the engineers can then proceed. The first step is to carry out an air blow. In this process, starting air is injected into the cylinders, but no fuel injection will occur, and the indicator valves will be kept open. The air will blow off any moisture or small solid particles within the cylinders. After the air blow, the indicator valves will be closed, and the engine will be tested on dead slow ahead and dead slow astern. After confirming that the engine is functioning properly, the main engine control will be transferred to the bridge and once again tested. For most ships, the main engine flywheel is directly coupled to the propeller shaft, which means the propeller will turn on the direction that the engine turns. So if during maneuvering and the ship needs to reverse the engine's rotation, it will be necessary to stop first and then give the order for a stern movement in order for the reversing mechanism to activate. Once the pilot comes on board, it's time to unmoor the ship. Ships are fastened alongside by means of thick ropes or mooring lines. There are mooring stations at the fore and aft, and for larger vessels, there is also a mooring station amidships. The deck department is responsible for mooring operations. The forward station is usually supervised by the chief mate, while the second mate is in charge of the aft station. Their task is to unfasten the ship's ropes from the port in cooperation with the linemen. During mooring and unmooring operations, ships are usually assisted by tugboats for easier movement and turning. The tugboats also come in handy in case the ship's engine suffers a malfunction. The engine will also be started and stopped as needed during this time to manage the slight movements and turns. After all of the ropes have been let go, the ship will now maneuver out of the harbor and to the open sea under the guidance of the pilot. Once the ship is out in the open, the pilot will disembark, the engine will be gradually adjusted to sea speed, and the ship will begin its sea passage. What I have shown you is a typical sequence of operation for ships when leaving port. Now, there are many different types and sizes of ships and many different engine designs as well. So there will be a few differences when it comes to specifics. But in principle, this is more or less how things are done. Because no matter how much technology advances and modifies the operation of machinery on board a ship, the basic principles will always remain the same.